and remiss. Okay. Okay. So I've just added this composite state to represent the fact that, first of all, we have some costs that are borne based on state. These are state-based costs. And then we're going to have some costs that are borne based on occurrence of an event. These are episodic costs. And so we represented the fact that obese individuals may be able, and then they're more likely to suffer an injury, and then they recover, and there's a period where they're disabled. And there might be disability costs imposed on the system, the workman's comp system or what have you, when they're in this disabled state. Okay, so ladies and gentlemen, I'd like now to go and start putting some things in place here. Okay, so the initial state pointer means when you come into the obese state, which of these substates will you start in? In which of these substates will you start? Yeah, it basically points where do you go when you come into this. When you come into obesity, into which of these internal states do you go? Yeah.
Because there might be a whole bunch of them that you can go to if it's a really complicated state chart within a state chart.
Yeah.
Even taking a look at that, just because able is above disabled doesn't mean you shouldn't necessarily start in able. Like, it could very well be the second somebody is obese, we assume that someone jabbed them with a needle, they inflated 2 times their size, and now are really hurting or something. But that really. Anyway, just because able is on top doesn't mean that that's the one you need to start in. So you need to tell it where to start.
Yeah. You need to tell in which internal state to start. And you'll notice that one of the virtues of describing this with a hierarchical state rather than 2 separate states, first of all, these people are in obese state. They're still is state active. Obese is still true. They're still counted as obese. But more than that, any outgoing arrows, for example, from obese state as a whole, like such as this one, apply to any of the states internally. So these folks here are still subject to losing weight and becoming, to losing weight, for example, and going to merely an overweight state. So this transition from the obese state applies by extension to any of the states within it. Yes?
Is there a way of assigning probability to the states on the start?
Upon starting?
Yeah.
Absolutely. I'd like to do that. Why don't we do that? I'll just show you how it's done. I won't do it for the entire model. Okay? Is that okay? Okay. So let's do that. It's very quick for the diabetes case. So I'll just do it. And you could tell by extension how it will be done here. Okay. So the question is: suppose we wanted the initial population, some of them to start diabetic. It's very common, right? You want people to start at different ages or different health states or what have you. Okay, so to do that, ladies and gentlemen, I think we're going to nuggetize this. So this is comments on hierarchy.